So in this project demonstration video, we will be doing the experiment to study the time period of any oscillating object using Arduino. So you can see we have taken a IR tracking sensor. It consists of a IR emitter and uh, an IR receiver side by side. And I have considered this stick as an oscillating object which is connected to a servo motor. So I can control the oscillatory motion in a continuous way. Since setting up a pendulum is tough here, so I have considered this object as an oscillating object. You can also try with a pendulum. It will give the same result. So this is my oscillating object connected to a servo, and the servo has been programmed already for a oscillatory movement of the stick. Okay, this stick is actually connected to the head of the servo. I guess you understood that. And now this is the Arduino board. I have made three connections, which is two for the VCC and ground. These two are VCC and ground, which are connected to the VCC and ground of the sensor, and the signal out of this sensor. This is the digital out sensor. So the digital out sensor has been set up at Arduino pin number 12. So I need to set up this digital pin 12 as input. Okay. So also this sensor has been set up in active low mode. Okay. So whenever it detects an object, it will give 0, and whenever there is no object, it will give 1. You can also reverse the order. Then you need to introduce some more calculations actually. Actually, no calculation. You don't need to include any calculation. You just need to change the program to swap the numbers. Okay. So I don't need that actually. That's why I just considered this as simple. Okay. So let's see how the oscillatory object moves first. Okay. Let me power up the device. So this thing moves like this. Okay. It is an oscillatory device. Now we need to determine when it passes over the sensor. Okay, so let's jump into the Arduino coding. I guess you can see the Arduino program in the side of the camera. So just have a look in it. So all since we have already discussed the program, so I'm not going to again explain everything. You can just check this and try to understand yourself. I guess you have understood. So let's proceed. So the program is written in a way that the integer variable x stores the digital read of the digital pin 12. Okay. So whenever there is a high voltage, the digital read will give 1 into x, and when there is a low voltage, it will give 0 to x. And we are uh, printing the value of x in the serial monitor, and there is a delay of 100 millisecond. Okay, so our accuracy should be zero point 0.1 second, right? So there is nothing much to express. Initially, we set up the serial monitor at 9600 baud rate and set up the pin number, digital pin number 12 as input. Okay, very basic programming. And in the lower section, we have opened the serial monitor. Now, when we connect the Arduino to the computer, it will start the it will start displaying the numbers. Okay, so let me first turn on the oscillatory device. Since I have already programmed the Arduino, That's why I need to turn on the oscillator device first. Now, if I connect the Arduino to the PC, it will immediately start showing the output. Okay, so let's start. Keep a look at the serial monitor. I am just connected. So you can see whenever it is passing the sensor, a red light is blinking, indicating object is detected, and the corresponding value becomes zero at the serial monitor. You can check it. Just minutely compare the both screens. Okay. Okay. So now what is the time period here? You need to just understand that. So time period is defined as the time taken between reaching the same position. So this is moving here and here, right? So now see, this start from here and it return to here. Now the tendency of movement is here in this side. So when this thing completes the rotation from here to here, it is the complete time period. So correspondingly, you can determine how to calculate the time period. So now we have a huge amount of data. Let's stop the program and check out what we can do later.